Thank you so much for joining us today. We're going to have an amazing panel, and thank you for joining us over these past 2 days. We've been really lucky to have a record-breaking attendance this year, and we're very excited to continue down this path and really give you folks a lot of just top-of-the-line, excellent subject matter expertise in these conversations. So with that, this panel is going to be about building resilient defense supply chains, and we are very lucky to have some amazing professionals who are in the fight right now dealing with a lot of these types of complex questions around supply chain resiliency. With that, I'm going to ask our moderator, Brandy Vincent, to come on up and bring our panel up, and we'll go ahead and get started.
Hello, everyone. Is this thing on? It is. Hi, please welcome our panel to the stage. So this is a reminder that for the last 15 minutes of this panel, we're taking questions from the audience. That's what those little note cards are for. Please submit those. We're really excited to hear what y'all are interested in hearing about as well. As you heard, I'm Brandy Vincent, Defense Scoop's Pentagon correspondent, and I'm super thrilled for this discussion about the challenges and opportunities around the U.S. defense supply chain. The way I sort of think about it is it's the networks of processes and entities needed to produce and deliver products for the military and its associated defense components. We have a super stellar panel up here. I'm really excited for this conversation. We've got Dr. Cynthia Cook, the director of the Defense Industrial Initiatives Group at CSIS, the Center for Strategic and International Studies. We've got Morgan Dwyer, who is the former Chief Strategy Officer for CHIPS at the Department of Commerce. We've got Dr. Dev Shenoy, who's the Principal Director for Microelectronics and Executive Director for the Microelectronics Commons in DoD's Research and Engineering Directorate. And last but not least, we've got Mr. Mark Stewart, who's the Senior Vice President of Operations at Lockheed Martin. So with that, we're just going to go ahead and dive right in. Dr. Cook, I wanted to kind of kick the conversation off with you, just drawing from your longtime research expertise on the defense industrial base. To kick us off, can you set the stage in the aftermath of the pandemic and with a lot of recent news reports about munition shortages, semiconductor crises, broadly, what is the current state of the U.S. defense supply chains and the components associated with them?
Well, thank you, and thanks to everybody for coming to our panel. That is a great stage-setting question, and I would like to start off by highlighting that supply chain challenges are not new. There has been increasing fragility over the last couple of decades as the costs of holding inventories has become more clearly identified. Supply chains have become more tightly coupled, more efficient, and thus more subject to disruptions. So COVID highlighted this challenge in a way that another series of DoD reports never could. The pandemic highlighted surge production on the low end, including for things like medical masks. It also was harder to access semiconductors, which are fundamental to so many consumer products like cars and dishwashers. My father spent 6 months of the pandemic washing dishes in the sink because I couldn't get a new dishwasher. So this hit consumers pretty directly. The second challenge more specifically relates to defense, and that is derived from lessons about the challenges in supporting Ukraine in its self-defense after Russia's illegal invasion. The U.S. and other partner nations rushed to support Ukraine, but it became clear fairly quickly that munitions inventories were insufficient to support a longer conflict. This is not a surprise to those of us who work in the acquisition community, but it was a surprise to people who worked in more strategy topics. But that said, the supply chain challenges illuminated by Ukraine are also not new. In fact, right before the invasion, DoD released a report on securing defense-critical supply chains, highlighting microelectronics, energy storage and batteries, castings and forgings, and kinetic capabilities. So the same topics that are challenging today. So the supply chain challenges have not been fixed since that point, but the difference is that they're getting the right kind of attention they need at the highest levels of the Pentagon and the Department of Defense. Leaders are tracking the vulnerabilities. They understand that, as Dr. LaPlante says, production is deterrence, and they see what our adversaries are doing in terms of investments in their own supply chains. China is investing in a wartime economy and stockpiling critical materials. Their support of Russia is also consuming. The term axis of evil, or one of my colleagues likes Legion of Doom, as our adversaries get together and learn from our lessons of partnership to create partnerships of their own. So DoD has responded with investments, but more importantly, they have responded with a strategy. The National Defense Industrial Strategy takes on this challenge directly with 4 strategic priorities, including resilient supply chain, workforce readiness, flexible acquisition, and economic deterrence. Workforce readiness, flexible acquisition, and economic deterrence, which is working with allies and partners, also support resilient supply chains. And let me just work in terms of workforce readiness, that there are several INSA interns here looking for jobs. So if anybody is hiring, please talk to Brandy after the session. So I will draw this to a close, in case you were wondering. I know you wanted to save room for questions, but the NDIS has already resulted in some specific funding. There has been $20 million in DPA funds to South 32 to accelerate an Arizona plant to create domestic production of battery-grade manganese. DoD has invested in Canadian companies, Fortune Minerals Limited and Lomico Metals, to build resilience in the cobalt and graphic supply chains. The DoD has a new modular metal parts facility in Mesquite. There's other investments in manufacturing innovation and manufacturing capability expansion and investment prioritization. So there are investments out there that are supporting the strategy that has been created to invest in resilient supply chains.
Thank you, and thanks for that stage setter. I think especially with some of your fellow panelists and what they've done with the CHIPS Act, that's such a good segue. So Dr. Shenoy, I want to jump over to you. I want to talk about for a little bit these challenges from your perch within DoD. I know last year President Biden invoked the Defense Production Act authorities explicitly for microelectronics supply chains. That was before the Chips and Science Act, which I know you played a major role in that time leading up. So what are the challenges explicitly associated with microelectronics technologies for DoD, which make up sensors, drones, and many of the capabilities the military needs for future fights?
Sure. So thank you for inviting me to this panel. Delighted to be here with this audience. So, when you think about semiconductors, microelectronics, we have certain unique challenges. A lot of the microelectronics that the Department of Defense requires, has to be custom, has to be boutique in many ways. When you think about strategic rad-hard microelectronics, when you think about electronic warfare, a lot of those capabilities are unique. If you could just source those from commercial industry, we wouldn't have a lot of the challenges that we have today with the department's needs and requirements. So that is the first thing to know, that there is a differentiated capability that the DoD needs when it comes to semiconductors, when it comes to microelectronics, that makes it even more challenging when you have supply chain disruptions, when you have supply chain issues. The Defense Production Act presidential determination was to support specific capabilities in things like printed circuit boards, advanced packaging, and so on and so forth. But really, when you think about microelectronics, it has to cover a very broad gamut, right? All the way from design, manufacturing, assembly, packaging, and testing. And the US has been dependent on a global supply chain for a lot of the microelectronics. In fact, today, we only have about 12% of manufacturing in the US. We were 37% of manufacturing back in 1990. So this manufacturing has dwindled over the years, and we are now trying to bring some of that manufacturing back to the US, make the supply chain a lot more robust and resilient. And so when you think about DoD's needs for microelectronics, which is of the order of 1%. So imagine the semiconductor industry is $500 billion. DoD contributes about $5 billion to industry's revenue. So because we are not potentially the preferred customer for the industry, it makes it even more challenging for us. So with all these challenges, and compounded by the fact that our systems are legacy systems in a lot of cases, which means that we need legacy microelectronics as well, not just state-of-the-art, not just leading-edge microelectronics. We need legacy parts. And we also have a need across many different technologies. It's not just leading-edge logic. It's not just memory technologies. It's not just analog mixed signal. It's not just photonics. And there's so many different capabilities that are needed when you think about microelectronics. And so it's all of these challenges that we're trying to address. And fundamentally, our strategy is we are going to leverage commercial industries microelectronics to the maximum extent possible. But beyond that, when you have to have differentiated capabilities, when you have to have boutique chips and so on and so forth, we take commercial chips, customize and adapt it for the DoD. So that customization, that adaptation process is where we focus on, because that way we are at the leading edge. And the differentiated capability we need, we can, to some extent, rely on commercial industry, but we may have to rely on defense industry-based companies as well. And that's what we've done recently through a lot of the programs that we've stood up. We've brought the commercial industry as well as defense industry-based companies together to work at the leading edge. And with a lot of the offices that we have, like within ANS and acquisition sustainment, we are ensuring that DoD has access to all of the microelectronics it needs, all the way from leading edge to state of practice, as well as legacy technologies.
And you've played a sort of leading role in standing up the Microelectronics Commons, which is part of DoD's solution to a lot of these challenges. So can you talk a little bit about that and how it stemmed from the CHIPS Act and sort of the network that your team is building?
Sure. So, when you think about the ecosystem for microelectronics, we've, for many decades, relied on other countries for doing a lot of the prototyping of semiconductors. We are really good at innovation in the US. National Science Foundation, Department of Energy Office of Science, DARPA, and other places support basic research, fundamental research. But a lot of that research doesn't get translated into prototyping. And I'm really referring to hardware at this point. And without that prototyping capability in the US, we have to rely on offshore suppliers. And that imposes certain challenges. One is we could potentially lose the IP in the process. We are not able to protect the IP in the US. It also means increased timescales for prototyping, because we've got to set up arrangements with other places and other countries. And then those arrangements can take a really long time. And then the co-location of the innovation manufacturing is also critical. In fact, there are studies that have been done to show that when there's co-location, geographically co-locating innovation with manufacturing, you can actually do a lot better, not just with innovation, but also with the manufacturing, because it takes multiple cycles of innovation and manufacturing. It's not a linear process when you just do the research and do the manufacturing in one step. There's multiple iterations that are needed, and therefore co-locating innovation and manufacturing is also critical. This is why we are supporting, through the Microelectronics Commons, prototyping facilities here in the US. And so the lab to fab gap, as it is called, that valley of death, as it has been known for many years, that's the valley that we are trying to address in terms of addressing the challenge of taking the research from the universities, from the startups, small companies, and so on, into manufacturing. Now, what we have done through the Microelectronics Commons is supported 8 hubs across various parts of the country. In fact, those 8 hubs include over 1,200 members today. It's been a phenomenal growth in the past year. It started with 600 plus members and has grown tremendously. And we are supporting 8 hubs, and those hubs include universities, startups, small companies, FFRDCs. Pretty much any organization that can contribute to the Microelectronics Commons is not just invited, is encouraged to participate and be part of Microelectronics Commons. Now, we are supporting 6 technical areas of interest to the Department of Defense, things like artificial intelligence hardware, electronic warfare, secure edge computing, 5G, 6G technologies, quantum technologies, and commercial leap-ahead technologies. So commercial leap-ahead technologies are those technologies that the department has identified as opportunities for ours, but other commercial industries probably not yet seen the opportunity. A good example of that is gallium arsenide technology. When it was first supported by DARPA, for example, commercial industry did not recognize the opportunity to gallium arsenide, but gallium arsenide is now ubiquitous. It's in communication devices, in a lot of different platforms and systems. So those are examples of technologies the department is interested in, but commercial industry is not yet identified as opportunities. And one example of that is high voltage silicon carbide. So we are supporting a hub within the Microelectronics Commons to enable those technologies for the Department of Defense. So those 6 technical areas, the 8 hubs, we formed a network, and that network includes, as I said, 1,200 plus members. There's over 35 states that are represented, over 100 colleges that have been included in this Microelectronics Commons, and we've initially supported $240 million worth of infrastructure, which includes everything from physical infrastructure, digital infrastructure, as well as human infrastructure. So in addition to the infrastructure, we are also going to be supporting technical projects to leverage that infrastructure. And very soon, we plan to announce project awards worth $280 million. And those technical projects across the 6 technical areas that I mentioned are going to help DoD sort of not just reinvigorate the microelectronics in the US, but also ensure that we can sustain the ecosystem in the longer term.
Awesome. And Dr. Shenoy recently got back from visiting those hubs, so I'm excited to talk about some of the prototypes you saw over there. Before that, though, Morgan, I'd love to hear from your perspective about sort of the broader national security goals of the CHIPS and Science Act, even beyond the Microelectronics Commons. You departed Commerce pretty recently, but can you talk about that and also maybe give us an implementation progress update from around the time you left?
Sure, happy to. I think I did depart the Department of Commerce a couple of weeks ago. I took a vacation, and I still can't stop talking about semiconductors. And the reason for that is because they are just so absolutely critical for national security. So really happy to talk about that today. So as a reminder, the CHIPS and Science Act authorized and then subsequently appropriated $52 billion for both manufacturing incentives as well as R&D investments. The majority of that funding actually went to the Department of Commerce to implement. The part of commerce that I used to work at focused on the $39 billion that was dedicated to manufacturing incentives. Dev talked about the importance of doing manufacturing and research and development together. You get a cycle of innovation when they're done together and co-located, and the United States has lost that manufacturing edge. And so part of our goal was to bring manufacturing capacity back to the United States, while another part of our program also invested in research and development. So when we think about national security and CHIPS, and part of the reason that I wanted to go work at the Department of Commerce, which candidly I'd worked at DoD, I'd worked at the White House, I'd worked in the intelligence community, more sort of hard national security. You don't always think about commerce as a really important player in the national security business, and that's changing. And I think the CHIPS Act has really sort of demonstrated why that should change. So, when I thought about semiconductors and national security, I thought about sort of 3 core pillars. The first we've already talked about today. The majority of the military's weapon systems today rely on a supply of chips that are produced overseas. That's obviously a national security issue, and that was one of the things that we thought a lot about and made investments to address at Chips for America. The second item, Cynthia mentioned, chips are central to economic security. They were the reason, chip shortages were the reason folks couldn't get dishwashers in cars during the pandemic. Even, taking another step back, the most advanced chips, the ones that power both your iPhones as well as artificial intelligence and all of the technologies that are really going to be critical to the future, those advanced chips, 92% of the world's advanced chip manufacturing capacity is located in Taiwan. I don't have to explain to this group why that geographic concentration in that part of the world is also a national security risk. But the third thing that I think is really important when you think about chips and national security is that connection between chips and the future of innovation, right? We are in a technological competition with the People's Republic of China. Technologies like artificial intelligence, quantum, biotechnology, those technologies are going to sort of pave the way for innovation in the future and are really going to be at the forefront of that competition. Chips are foundational to every single one of those emerging technologies. So, I tend to think of semiconductors as really being the single most important element in our technological competition with China. That was my motivation for joining the Department of Commerce from places like DoD and the White House, because I just think chips are central to our national security. So an implementation update. Again, my knowledge is dated by a couple of weeks, although I did see some news yesterday that the team announced an award to HP, which is really exciting. But I think that when you think about implementation of the CHIPS and Science Act of the Department of Commerce, we got funding in August of 2022. And when funding was appropriated, there was no one at the Department of Commerce to implement this program, literally no people. Which I think, when you think about the Pentagon has a lot of sort of institutional capacity, the Department of Commerce doesn't. And so one of the first things we had to do was actually hire people and build a team. We rapidly scaled a program office at a speed I think is probably unprecedented in government. My team alone, I led our strategy team. We had I started with 5 people. I scaled that team to over 50 federal employees in less than 4 months. So we had to rapidly scale a team of professionals. We had to figure out how are we going to accept applications? What's our application process going to be? We had to write a regulation for our guardrails rule, which is really important for national security. So we had to write a regulation, put that out for notice and comment. And then we had to actually start implementing our application process. Love to talk more about the application process and how we thought about things at CHIPS, but it was a really iterative process, multiple steps. One step was, we called it pre-applications. It allowed us to really interact with industry in a way that I think was unique, and really provide them with feedback on what our national security goals were and what we wanted to see in their full applications. We then had to review, so we reviewed hundreds of pre-applications. We then had to review applications, and then we had to actually begin making preliminary awards. The program made a ton of really exciting preliminary awards, award announcements up and down the supply chain. We made several investments in legacy chip capacity that'll directly support the defense industrial base as well as the automobile industrial base. We made really exciting investments in leading edge capacity. Remember, I told you 92% of the world's advanced leading edge capacity is currently in Taiwan. As a result of our investments that we're on track to make, at Chips for America, by the end of the decade, we anticipate 20% of the world's leading edge capacity will be located in the US. So as a result of the investments that the program was making, we're going from 0 to 20, which is huge. We also made really exciting investments in upstream suppliers as well as downstream suppliers, particularly focused on advanced packaging, which is critical for artificial intelligence. And apparently we made an announcement yesterday. So the team, is absolutely fantastic, continues to churn out, preliminary announcements. Now what they're doing is moving into sort of a due diligence phase with each of these companies. They then get to a place where they start giving out money. All of the awards are milestone-based. So it's really, they're really just getting started now. There's tons of work left to do. But I think, when you think about the overall goals in national security, the team made tremendous progress. And I think really demonstrated a new approach to industrial policy that I hope others can learn from and implement in the future.
Absolutely. Thanks, Morgan. And that's another great segue to our final panelist, who is going to give us our defense industry perspective on this panel. Mark, I really want to hear about what you're seeing from that lens. I know also Lockheed Martin recently announced initiatives to support the CHIPS and Science Act, maybe some things around foundries. So can you expand a little bit about that and how that's really working to strengthen the supply chain?
Absolutely, and I think the panelists here have actually described the environment that Lockheed Martin, as well as other members of the DIB, face, the issues that we're facing in the environment day to day, 7 days a week, 24 hours a day. And so where I want to come from is just, okay, they've described the environment, but what is industry, what is Lockheed Martin in particular doing about it? How are we progressing? And I will tell you, I think, Doctor, you really set me up well in that it's looking at everyone and anyone that can contribute. Now, we talk about microelectronics, and Dr. Cook also spoke about the batteries, magnets, and the list. I have a lot of critical items, not just microelectronics, but we'll stay on microelectronics, is that you look at the strategic relationships that Lockheed Martin has invested in, Global Foundries, for example, Intel, big company, right? And then you spoke also, Doctor, to startups, Zero ASIC, investments with Zero ASIC in startup type companies, as well as internal with LLCs and our forward edge ASIC capability that we've developed over the last several years. So what are we trying to get out of these arrangements? And the setup was absolutely perfect in that, yeah, we are working on future generation designs. Microelectronics is a wide variety of them. It goes down to RF on chips, it goes down to analog on chip, high processing on chips, et cetera. But when we look at our 21st century security that we're trying to adapt, you think about what it is going to take to bring that computing power to the edge, right? And it's going to take, data streams from, a lot of different platforms, a lot of bandwidth needed, and the time and the latency that we need at those chips has to be at the edge. So how do I get a system on a chip? That's going to be advanced technologies that the doctor spoke to. When you look at that technology, 7 nanometer and less on a chip, right? Now, on the other hand, and we were talking before the panel started, is that, we started working with the administration on the CHIPS Act before it was signed into an act, as to what we had to get out of, the efforts that the act was pointing to. Yeah, we've got to look at future needs, and future needs are not all that much in the future. But also we got to look at what we have and what we have fielded today, right? And we look at that technology, and that, when you look at, let's take a typical munition, probably has somewhere around 130 to 140 microelectronic parts on it. And that's just one munition. And you look at that technology, it's typically 75 nanometer and up. So out of the act, and what we have to work with Global Foundries, with the Intels, with the startups, is not only going to the future, as we try to develop 21st century security at the edge with that capability, but we also have to as well with the heritage equipment, right? And that's building, 75 nanometer type equipment. And to your point here, and you gave it, I think, a large number. I think you said 5% is the demand across.
1%.
Yeah, 1%. That's the number I know. I represent the defense industry base, Lockheed Martin being one of the largest players in the DIB, and we're 1%, and we're going to market with these arrangements, saying, hey, look, we only need 1%, and it needs to be very, very highly reliable because the mission depends on it. So that's the fight we're in.
Absolutely, and I want to stick with you for a second because of what you just said about the highly reliable and secure. I know ethical sourcing of materials is a really important element, especially for the U.S. industry. Can you speak a little bit to that criticality and sort of how y'all are approaching concerns around that?
Yeah. As a DIB prime, we're responsible for our supply chain. And, and I'll describe Lockheed Martin's supply chain because it's really important that everyone understands this. Yeah. So actively, Lockheed Martin, with active suppliers, we tend to be between 13,300 and 13,700 active suppliers at any given time. 67% of those are small business. right? So, and they occupy about 18% of our annual spend in the supply chain in any given year. So when you look at that, and you look at what we buy, Lockheed Martin does not buy these critical materials. We really don't buy a lot of microelectronic piece parts, right? Our supply chain does. And when you look at it, 67% of them are small business. So how do you maintain an ethical supply chain with, you know, the diversity that we have? And I will tell you, the criticality of the small business in our business is huge. And it only takes one supplier, obviously, to have an issue and an ethical issue. So we've got a very robust supply chain onboarding process that we evaluate the suppliers. Obviously, you know, contracts and flow downs, et cetera. We instill, you know, we give them actually the schooling, if you will, or the education on what it means to be an ethical supplier to the US government. We actually, where we can, we give them tools to operate within, cyber tools, illumination tools, to look deep into their supply chain, to fully understand their supply chain, and understanding where not only conflict countries arise, but also human trafficking. There's a whole bunch of other categories that we have to survey and audit our supply chain on. And they're all very, very important. So we start with that. You might think 13,300 is a small number of suppliers. When there's 67% and they're small business, you know, we got to bring that education to the supply chain, and we work really, really hard on that.
Thanks for that. Another very sort of crucial aspect of all this is securing the defense supply chain from complex cyber threats as well. We recently heard Cybercom's commander warn that China is actively targeting America's defense supply chain. So Dr. Cook and Morgan, I really want to talk to you a little bit about that. Morgan, I'll start with you. What types of cybersecurity threats are agencies really confronting in this space? I've heard software, counterfeits. What else, and how is the government sort of addressing that with chips?
Yeah, so you know, I think, well, I'll speak to how we thought about security at CHIPS, which is sort of a unique challenge because a lot of the companies that we were working with never really worked with the US government before. And so unlike sort of the Lockheeds of the world who, you know, have these sort of security-minded and security-focused interactions with their suppliers in particular, that's largely new for the majority of chip manufacturers around the world. Now, we did provide preliminary funding for several trusted foundries. That's sort of in a different category. But the way we thought about security at Chips for America was sort of in 4 buckets, and because I think those are where those sort of key threats are. One is obviously cyber, and thinking about the security of the networks that all of the facilities are operating on. The one that made me the most worried, though, was actually cyber-enabled attacks through the supply chain. Yeah. And you know, I think maybe it's from my experience working at the Department of Defense and working at defense contractors, but realizing that one of the most significant attack vectors is through some of those smaller suppliers that are, you know, 1 or 2 tiers down in the supply chain. And you know, I think in the semiconductor industry, one of the observations that we had is, you know, semiconductor manufacturers, particularly the commercial ones, are really effective at managing their supply chains because they have to be. It's core to their business. But security is not necessarily core to their business. And so one of the things we thought about was how can we at Chips for America try to raise the bar of security across the semiconductor industrial base. And so really looking for ways to partner with the companies that we're awarding funding to help them understand what best practices were in cybersecurity and supply chain security, in operational security as well. You know, we thought a lot about insider threat, as well as a lot about physical security. And then another threat vector that you know, intersects with cyber but is somewhat distinct is counterfeits. That was something that Congress actually asked us to focus on. The CHIPS Act legislation specifically contained an emphasis on counterfeits. Counterfeits are particularly a risk at the more mature parts of the supply chain that affect the defense industrial base. And so we were really focused on working with our applicants and eventual awardees to understand what are their protocols for protecting their manufacturing processes from all 4 of those threats. threats, and then how can we work with them and partner with them over the life cycle of these projects to raise the bar overall in their security. I think the thing that I still worry about this when I think about semiconductors in particular, when you think about sort of the broader strategy with respect to semiconductors, the Biden-Harris administration enacted a really impressive set of export controls focused on leading-edge semiconductors to deny the People's Republic of China access to leading-edge semiconductors. As a result, it's essentially impossible to manufacture or to gain access to leading-edge semiconductors in the People's Republic of China. We've seen sort of this playbook before, right? We've seen industrial espionage target the defense industrial base. And when I think about some of the actions that we've taken, it seems to me that we should expect China to be even more determined to gain access to the innovation and the know-how that is resident in the United States. So it was something we took really seriously at Chips for America, making sure that we were doing everything we could to help raise the bar for security.
Absolutely. Dr. Cook, do you want to add anything?
I'll follow on that. I think my co-panelist here described the risks really effectively, as well as what the government is doing to try to address the challenge. Taking it from a different perspective, I speak with a lot of small and innovative businesses, and the challenge for them is the cost and uncertainty involved in following the cybersecurity standards and making sure that they are able to present themselves in a way that they're safe and secure. This isn't just US businesses, it's also the innovative and emerging businesses from our partner nations who view this as a big challenge. A lot of times they sell to the large primes of this world, the Lockheed Martins, but it is not necessarily the prime's job to make sure that everybody in their entire supply chain understands these. I mean, they do that, or they do take on some of that role, but really the government if the government would like to access the emerging technology industrial base, part of the strategy of ensuring security needs to be bringing the small and innovative companies along so that we can access their innovations and intellectual capital and improve the innovation of our industrial base. So that is where we will need, as we continue to increase the security of our supply chains against cyber threat, we will need to continue to focus on what small and emerging innovative businesses need to make sure that we can continue to access their capabilities.
Absolutely, and I'm glad you brought up the international angle because that's another big part of it. I was recently at the NATO summit where they announced new partnerships between the NATO allies and countries in Asia, including Japan and South Korea. And part of the reason they answered my question about why they did that was because they said, point blank, the transatlantic alliance does not have the production capacity to create the chips and other parts of weapons that we need for the future, so we must. And so there's no question that making it easier to work with international partners is a big part of this. I was wondering real quick if, Mark, you wanted to chime in at all about what y'all are doing there?
Yeah, absolutely. And I think what set it up is Dr. Cook, stated we came out of the pandemic, and we had a lack of labor, in the right places for supporting the DIB. And what compounded that is, the invasion on Ukraine. Yeah. Right? So if you look prior to the pandemic, we were pretty much within the domestic supply chain for the DIB. We were level loaded at what I'll call a peacetime rate for the systems that are being called upon. And now, with the invasion of Ukraine, in some cases, depending on what system it is, they have doubled, right? So when you look at that creates new gaps within the domestic supply chain. And to your point, internationally, with the demand and increasing, let's say, munitions of our Javelin, our Gimlers, our HIMARS, and our PAC-3, those production lines that will be produced, internationally with our allies, they have capability in their supply chains, and it's upon us here in the U.S. to look at these product lines and be able to say, hey, look at, This typically has come from the U.S. We've got, a deficit or a shortfall here. How do I get that capability, and a sovereign capability in one of our allied countries? So as you look at Australia, we've got a good footprint in Australia. It's growing. We got a lot of onboarding programs. We're developing hand in hand with the Australian government, as well as our industry peers, that supply chain, right? And the supply chain, not only to it'll have obviously some domestic content out of it, but how do we get a sovereign content in each one of these countries so that we do have another source for supply other than the domestic U.S. supply. It's going to be critically important because you look at the numbers of what has been expended in the Ukrainian issue. It's much larger than what we've accustomed to in our peacetime stockpiling programs we've had up to this time.
Absolutely. I'm going to remind the audience one more time, if you haven't submitted a question, please do. One last one for Dr. Shenoy. I want to hear a little bit more about what you saw when you went out to the hubs. Talk to us about the prototypes and what might be coming out of this. And then also you're expecting potentially some announcements before the end of the year. Talk to us about what's in the pipeline as well.
Yeah, so, it was an exciting roadshow. The 8 hubs that we had selected, we had an opportunity to visit each of those hubs. And there was a lot of representation from the members. All of the members obviously weren't at each of these hub roadshows, but a lot of the members were at the roadshow. And that really helped us understand what organizations are coming together, how are they partnering, how are they sharing information, how are they teaming to develop projects and so on and so forth. And it was very insightful. In one example of what I'm talking about is when we were in Boston visiting one of the hubs, we had a chance to visit with the governor of Massachusetts. And the governor and the economic minister there promised to sustain that hub through co-investment. So it's not just about federal government funding, it's also about ensuring that there's co-investment from state sources, other local sources, and maybe private capital as well, to ensure that there's sustainability of the Microelectronics Commons. Because when you think about the Commons as a network, and when you think about the goals of the Commons, which is prototyping in the US, onshoring the manufacturing in the US, we want to ensure that beyond the 5 years of federal government funding, there are private sources and other sources of capital to sustain the Microelectronics Commons. And we saw evidence of that early on through the roadshow. So that's really encouraging. And it's also gratifying to see partners that would normally not come together and think about ideas. And they have ideation events. They have a lot of brainstorming that they do internally within the hubs. Because the way we've structured the Commons selection processes, we, for example, invited each of the hubs to propose 15 projects per hub. So those 15 projects obviously come from a number of members within a particular hub. They have their own selection process within a hub. So the hub that I alluded to in Boston, for example, they had something like 75 projects that the members proposed, and they had to down select to 15 projects that they then sent over to the government to evaluate and select. So we have a sort of a tiered approach to the evaluation process, which is going to get even more meaningful going forward, because with 1,200 plus members in the Microelectronics Commons, you can imagine the number of ideas that are going to come in. What I've also done in setting up the Microelectronics Commons is to form a governance structure. I've instituted what's known as a Commons Hub Board, which consists of the 8 hub leads of all of the 8 hubs. And then so that hub board will inform us of what are the technologies we need to be supporting in the future. So essentially, it's like information that they provide to us, and then I've set up a separate board called the Board of Service Executives, which consists of SES-level executives from the Army, Navy, and the Air Force. And then they, in turn, inform us of what are the needs and requirements for the Department of Defense. And then so through these boards, we're ensuring there is a really good, not just a synergy, but also a plan, a road mapping process that'll ensure the department has the technologies that it needs, the capabilities that it needs in the future. So the roadshow was really inside from that standpoint.
Absolutely. And is there anything else you want to share about announcements we can expect before the end of the year? I know you mentioned hundreds of millions of dollars. So.
Yeah. So, for the DoD's Chips and Science Act, we have $2 billion over 5 years, $400 million per year. And we've, in that initial tranche, invested $240 million for infrastructure, as I mentioned earlier. And the next round, we're going to invest in technical projects. That's $280 million worth of projects. So each of those 8 hubs submitted 15 proposals. We are going to down select to a certain number, depending on the funding that's available. And then so we're going to announce those projects fairly soon. And so that's the next step in terms of trying to get the hubs to propose technologies and capabilities for the department. We're going to do this on an annual basis. Every year, we're going to put out a call for infrastructure as well as call for projects. And then so that's the opportunity the hubs have to propose capabilities to the department.
Great. I'm excited to see what happens with the Commons. We're going to go into audience questions now. This one we're going to start with. They want examples. So what are some of the examples of major supply chain vulnerabilities pertaining specifically to cyber that you're seeing right now?
I can actually talk about, so cyber was mentioned. Obviously, it's very important, right? Cyber is critical. We need to be cyber secure. But what is also ignored, at least for microelectronics and semiconductors, is the hardware security aspects of it. Now, our strategy, department's strategy, has been to leverage commercial industries, commercial off-the-shelf, COTS as we call it, to the maximum extent possible. Something like 80% of DoD's microelectronics is COTS, commercial off-the-shelf. But when you think about COTS, which is sourced from a global supply chain, designed somewhere, maybe in some country in Asia, manufactured somewhere else in some other country, assembled, packaged, and tested somewhere else, we have no clue who's designing it, what they have in those chips. And so the malicious Trojans that they can easily insert into billions of transistors, it's very hard to detect unless you do reverse engineering. And reverse engineering is not an easy process to do, particularly at the leading edge, 5 nanometer technologies and below. And so hardware security is a very critical challenge for the department. When you think about doing a lot of the design onshore at the leading edge, it's hundreds of millions of dollars. If you want to design a chip at 5 nanometers, it's $500-600 million. So if you think about DoD designing it, manufacturing it, assemble, package, test internally, all through DoD control, it's going to cost a lot. And then you can think about FPGAs, field programmable gate arrays, where to some extent we have control over the software that we program into the chips. And so there's a little more control, but there's still vulnerabilities in the FPGAs as well. And so I've talked about COTS, I've talked about FPGAs, and I've talked about ASICs where we can completely design internally, but it's going to be cost prohibitive to do that. So the hardware challenge, the hardware security challenge, is something we continue to grapple with. We are going to set what are known as best practices, standards, to ensure that the supply chain adheres to those standards and best practices. So we have, to some extent, an ability to try and look at the data that we get from the supply chain and be informed to the extent possible of the assurance of those chips.
Thank you. This is a question for Ms. Dwyer. Morgan, you stated that $39 billion is being allocated towards manufacturing incentives. What role has or will education play with respect to chips and hiring the workforce? If the goal is 20% of this advanced technology to be manufactured in the US within 10 years, this will require a workforce that's highly educated and highly technical to meet this goal. Is part of the $52 billion being allocated towards education of the workforce?
I am so, whoever asked that question, I'm so glad you asked that question.
Me
that
too.
Is, one of the things that I really loved, again, I'm a national security person, but what I really loved about going to CHIPS was it's just such a multidimensional problem, and workforce is absolutely central to our national security. And, I used to think about if we can't build and operate the facilities that we're investing in, we don't get any of the security that we wanted. And so the answer to the question of is any of the $52 billion being allocated to workforce is yes. And that's something that was really excited to play a part in. So how are we thinking about workforce at CHIPS? Again, the part of the Department of Commerce that I worked on was the manufacturing facilities. When you think about the workforce that's required in the manufacturing facilities, it does include highly technical folks, with engineering degrees and PhDs. It also includes lots of technicians that actually don't require college degrees. And the thing that I never thought I would go work on is it also requires a really robust and large construction workforce. And so we spend a lot of time thinking about not only those really high-end engineering PhDs, but also how do we build a workforce pipeline in STEM, in community colleges and apprenticeships, and in training programs for construction workers. So one of the things that we did was actually, in several of our major awards, included an award that went to the company for them to spend on workforce initiatives. And the idea there is, the company has to be able to build and operate the fab. And so they have the best understanding of what their workforce challenges are, and we essentially gave them funding to help kickstart a workforce program. Now, the idea behind kickstarting that workforce program is that is initial funding. All of the companies have to be making investments in workforce just to even apply for our funding. And we're also, really looking forward to partnering with private sector investors in workforce as well as state and local governments. When we were thinking about sort of building facilities in places like Texas and Arizona, you are really building a community from the ground up. And so, our funding was seed funding to kickstart this work, but essentially, you were, reshaping the fabric of communities across America, which is part of the reason I got up every day after being really tired at CHIPS, because we really were sort of reshaping the workforce from construction workers all the way up through PhDs. So there should be more, I think, information about exactly what our workforce strategy is. We also had a regional economic development strategy that we released right before I left, which I encourage folks to take a look at, because I think that piece of truly industrial policy is really localized, and it's focused on people and communities and building pipelines of opportunity to good-paying jobs. And it's something we took super seriously at CHIPS, and we're happy to dedicate money towards.
Thank you.
Can I jump
please.
in there? When I talk to industry, right now hiring is one of the biggest challenges that they face. So these initiatives are absolutely necessary. And that goes beyond semiconductors to other sectors of the industrial base as well, with a lot of challenges finding good people and keeping them employed in the factories when the example we usually hear is that folks can make as much in an Amazon warehouse or working at Chick-fil-A. So the companies I talk to are taking this very seriously and looking at a range of investments in the workforce to make sure that they have the workers they need. It's also part of the National Defense Industrial Strategy, so other parts of DoD are engaged in it as well.
Yeah, and I'd just like to add as well, being the industry person here, is that, we have a lot of programs at the corporate level for developing technicians, all the way from technician, up through the universities, local arrangements with colleges, universities, etc. Too many programs really to stay here and list. But I would say also, too, beyond CHIPS Act, I mean, obviously, defense industry base, Lockheed Martin's, internal IRAD is hand in hand with so many universities. Probably easier to list the number of universities we don't work with than those that we do. So it's really broad involvement with universities in our IRAD programs as well.
Just as an aside, I've heard that cake decorators make very good welders.
Yeah, I can see
That's important for the future, potentially. And Dr. Shenoy, within the hubs, I know FFRDCs are involved in this. Is there a sort of education or academic component?
Yeah, we absolutely have a workforce development initiative. We've allocated about 5% of the Commons budget for workforce development. We've been receiving a number of ideas, micro-credentials, stacked micro-credentials where you don't have to go through a full undergraduate degree, for example, to be able to take up a job in a specific companies and so on and so forth. What I'm hearing is that there is a need for, specific skill sets. At the community college level, for example, it's not just about PhDs and masters and so on and so forth. You need certain skill sets that are obviously not available in the US. And so we need to be a little more targeted. There's an example of a program that I keep citing in New Hampshire. I believe it was Senator Shaheen that had proposed that idea, which is to have, a community college train students over, let's say, like an 8-week period, and 95% of those students make it into BAE systems in this case. And then so targeted programs are critical because we do have some notion of what those numbers are, 100,000 jobs and so on and so forth. But I think we need a lot more fidelity into what the demand is across disciplines. For example, how many chemical engineers, how many designers, how many, physical facility technicians, and then so on and so forth. So understanding the demand signal with a lot more fidelity, with a lot more clarity, I think is critical, because a lot of the focus on workforce development initiatives is things like, okay, how do we set up a course curriculum within a particular university to train students in microelectronics? But I think unless it's targeted, unless it's matched to demand signals at various state levels, for example, I don't think we're going to be doing as well.
Thank you. Well, that's all the time we have for this panel. I just wanted to quickly thank INSA and AFCEA for hosting us, and our panelists for a great conversation, and y'all for joining us. Hope to meet you later on today, and please enjoy the rest of the summit.